Hello and welcome. In this video, we'll solve some examples based on a Z transform. Z transform, we know that Z transform is used to analyze discrete time signals and system. Definition of Z transform is n varies from minus infinity to infinity, x of n, z raised to minus n. Let's solve one example. Find Z transform and draw its ROC of following sequence x of n is equal to z raised to n u of n. Now we know the definition of Z transform is x of z is equal to n varies from minus infinity to infinity x of n z raised to minus n. Now here x of n is a raised to n u of n. Put it, x of n is a raised to n u of n. If you know u of n, it exists for n greater than equal to 0. That is, the existence of u of n is from 0 to infinity and amplitude is 1. That means this a raised to n, whatever is existence from minus infinity to infinity, but this a raised to n get multiplied with u of n whose amplitude is 1. That means this amplitude get multiplied with 1, but this u of n is 1 only for n greater than equal to 0. For n less than 0, this amplitude is 0. That means only for n varies from 0 to infinity, this a raised to n get multiplied with 1. Otherwise, this a raised to n get multiplied with 0 for n less than 0. That means from minus infinity to 1, this term becomes 0. So the limits of this n will be 0 to infinity, and here u of n is 1. So this 1 there is no need to write here. N varies from 0 to infinity, a raised to n, z raised to minus n, and this u of n is 1 here. Now let's solve it. Let's combine the power n here. A z raised to minus n raised to n, 0 to infinity. Now observe this infinite series or infinite addition from 0 to infinity. If you remember your lower standard, it is infinite geometric series. And we know the solution for infinite geometric series is n varies from 0 to infinity, b raised to n is equal to 1 upon 1 minus b, where this b is less than 1. Amplitude of b is less than 1. This is the infinite series. You need to remember it. So same here, we can apply this as an infinite series. Here b is nothing but a z raised to minus 1. So here, if we apply infinite geometric series, our summation will be 1 upon 1 minus b. b is a z raised to minus 1. Where b should be less than 1 means here b is a z raised to minus 1 mod less than 1. Same we can write as a z raised to minus 1 means a upon z. Now if we'll take this z this side, it will become mod a less than mod z. That is mod z is greater than mod a, and we can write like this: mod z is greater than mod a. This is nothing but, this restriction is nothing but, we call it as a ROC, region of convergence. Means this infinite geometric series is 1 upon 1 minus a z raised to minus 1 only if this a z raised to minus 1 is less than 1. That means nothing but mod z is greater than a. For this reason, for all the values of z where its magnitude is greater than mod a, this converge. This x of z is 1 upon 1 minus a z raised to minus 1, some finite value. Only for mod z greater than a, that's why this is called as a ROC, region of convergence, for this x of n. Now let's draw it graphically. Our x of z is 1 upon 1 minus a z raised to minus 1, and ROC is mod z greater than mod a. This we can write as a z upon z minus a. Z raised to minus 1 will take z upon z, a upon z, and when this z will come In the numerator, it becomes z upon z minus a. ROC is mod z greater than a. So we can write it in a generalized form because we will require this formula when we will take inverse Z transform. So for any sequence which is in the form of a raised to n u of n, its Z transform is Z upon Z minus a and mod Z greater than mod a. So instead of a, here can be any other number like 1 by 3 raised to n, 1 by 2 raised to n, like this. And this u of n is indicate that your signal a raised to n u of n exists only for n greater than equal to 0. That means this signal is causal signal, we can say here. Now let's draw this ROC graphically. This is your Z domain, real axis, imaginary axis. Now all the values of Z for which it is greater than mod A. To show that, we need to draw a circle whose radius is a. So this is a circle whose radius is a. Now all the values of z for which it is greater than mod a means it is the exterior part of this circle whose radius is mod a. So for the sequence a raised to n u of n, the ROC is mod z greater than a. That is the exterior part of the circle whose radius is a. So here we can write next property of ROC of Z transform is if x of n is infinite duration, a raised to n u of n is infinite duration, right-sided sequence. Why right-sided? Because u of n exists only for n greater than equal to 0. That is all the positive values of n. That's why this a raised to n u of n exists only for positive values of n, right-sided sequence. But its duration is infinite, 0 to infinity. So infinite duration right-sided sequence, then the ROC is exterior part of the circle having radius mod A. So this is next property of ROC of Z transform. For the previous property, you can go through the previous videos. So here we have taken a raised to n u of n. Now instead of a raised to n, there can be other type of example like 1/2 raised to n u of n. The answer or procedure is same to find the a raised to n u of n. Here only a is 1/2. So your answer will be z upon z minus a. A is 1/2. Where ROC is mod z greater than a is 1/2 here. So like this, you can find the Z transform for generalized term a raised to n u of n. A can be any other value. Same steps you have to follow to find the Z transform. Thank you.